Hey guys, it's Tamara Thompson in Coach Moore's second period class, and you guys are learning 13.1 operation with function.
Yo, what's up, man? Coach Moore here. We are going to go over this 13.1, guys. Hey, listen, make sure you watch the videos for this unit. I've reviewed the test. I don't think it's that strenuous. It's a lot of stuff you did already. It's just a matter of you putting forth the effort, you trying to master this content. All right, let's go ahead and dig in. Hey, right here we're performing operations with functions. Okay, so for this first part here, let me clear this off because I've used this a couple times today. Oops, didn't mean to do that. There we go. All right. We're going to perform f of x plus g of x, okay? And I'm just going to walk through the example here, and I'm going to kind of scribble. All the steps are here, okay? I'm just going to do it again so you guys can see where every point comes from. Right here we got the function f plus the function g, all right, of x. All right, that's the same thing as saying f of x. Well, these are in terms of x. That's all it is in terms of x. All right, so there's no numbers in place of x. It's just x. So what we're doing is we're adding the function f, 4x squared plus 3x minus 6, and we're going to add 2x minus 2. Now notice, man, all of this is adding like terms. Okay, there's a 4x squared. There's no other x squared here, so I have 4x squared in my final answer. All right, I have a 3x and a 2x, so 3 plus 2 is 5. So that's 5x, and I have negative 6 minus 2, that's negative 8, guys. We just add like terms. Let me make that 5 look more like a 5. There we go. There's our final answer, which I have right here, guys. I'm just talking through it. All right, on this next one, you have f minus g of x, or f of x minus g of x, okay? There's just two different ways to look at the same exact thing. All right, but what you have is, as it's written right here, you have the function f minus the function g. The lot of errors I see is all because of this minus sign right here, guys. You always, when you have minus, have to distribute the negative. All right, so you should have something like this. 4x squared plus 3x. Hold on, my pen's on the fritz. As it was the last few videos. I don't know what's wrong with this thing. Plus 3x minus 6, and we're going to subtract. All right, I put the parenthesis here, guys, because we got to distribute the negative. You always have to distribute the negative, okay? So that's 2x minus 2, all right? And when you do that, guys, distribute the negatives, you get 4x squared plus 3x minus 6 minus a 2x and plus a 2. And from there, again, it's just putting like terms together. So you have 4x squared. There's not another 4x squared, so that will stand alone. And then you have 3x minus 2x. Well, 3 minus 2 is 1, so that's 1x or just x. And then you have negative 6 plus 2. Well, negative 6 plus 2 is still going to be negative, and that's a negative 4. All right, so there is our final answer right here, okay, of f minus g right there, okay? Now, with that being said, man, let's look at this you try. All right, this is the meat of the problem, or the meat of the notes, so you can see it and work it out on your own. Actually, I'm going to leave that there so we can refer to it. Let's get another color. All right, right here we're going to do f plus g first, f of x plus g of x. So we have f of x, 5x minus 6, and we're going to add x squared minus 5x plus 6. That's g of x, okay? Again, it's just like terms, okay? So you have x squared because it stands alone, and then you have 5x minus 5x. We have a positive 5 and a negative 5. Of course, those cancel out, right? So that's 0. And then you have negative 6 plus 6. Again, positive and negative cancel out. That's 0. So what we have here is x squared. This equals x squared, okay? This is f plus g of x, okay? Now, we're going to do the next problem here, and we're going to go not g, but f minus g of x. All right, and what that means is we take f, 5x minus 6, and we're going to subtract. Notice I put the parentheses again because I have to distribute the negative. G of x, which is x squared minus 5x plus 6, okay? Distribute your negative, so you have 5x minus 6 minus x squared plus 5x and minus 6, all right? So now, when you solve this out, the x squared goes first, or in this case, negative x squared, it stands alone. Then I have positive 5x and positive 5x. Well, that's 10x. All right, and then you have negative 6 and negative 6, which will give you negative 12. All right, this, guys, is our final answer, okay? All right, that's for adding and subtracting functions. All right, let me clear this off real quick. Boom. Okay, and let's go ahead and look at the rest of this. Okay, now multiplying and dividing functions, okay? Multiplying functions, guys, I've noticed that a couple of weaknesses I've seen in the past have been when multiplying functions. Multiplying functions or polynomials or whatever. Foiling is still an issue. So, guys, break this thing apart, man. You see right here we have g times f. All right, this is g of x. This is f of x. We're going to multiply those two. So when you go g, you would have this right here, 2x minus 3 times 6x squared minus x minus 12. All right, my suggestion is break this apart. All right, we're going to take this, because you know with foiling, you would do this first one times everything over here. Well, let's do that. Let's go 2x times 6x squared minus x minus 12. All right, and then let's do the negative 3 right here. See, that's negative 3? So we're going to do negative 3 times, again, everything over here. 6x squared minus x minus 12. Now, if you're comfortable with foiling, man, foil away. This essentially is foiling. All right, it's just breaking it apart. Now, when you do that, what you're going to get is this tidbit right here. I'm going to go ahead and do it, though. You have 2x times 6x squared. That's going to be 12x cubed. All right, then you have 2x times negative x. Well, that's negative 2x squared. And you have 2x times negative 12, which is negative 24x, okay? Then over here on this portion, you have negative 3 times this, 6x squared, so that's negative 18x squared. And then you have negative 3 times negative x becomes positive 3x. And then you have negative 3 times negative 12, which becomes a positive 36, okay? And now just simplify all the like terms, okay? So I have a cube here, 12x cubed. There is no other cube that is alike, so I want to go 12x cubed. Then I go x squared, negative 2x squared, and there's a negative 18x squared. Well, negative 2 and negative 18 adds. If you combine the terms, you subtract both of them, you get negative 20x squared. And then you have negative 24x and positive 3x. Well, negative 24 plus 3 is going to be negative 21x. And then you have the constant of 36 plus 36, which is this answer right here, guys. Okay. All right, take a second, soak that in, man. Take your time when you're multiplying on your assessments, your quiz, your test, and even your practice. All right, any quick checks you have, so you can help yourself out right there. All right. Now, all right, guys. Now for division. All right, we got f divided by g, the function of f of x divided by g of x. Okay. And apparently, here's f. And here's g, so we're going to divide the two like so. Now, what happens is, guys, you've got to factor this, all right? You got to reach back in your bucket, all right, of tricks and pull out your factoring techniques, guys, to factor this, because you got to factor everything, all right? So you will factor this, you get 2x minus 3 times 3x plus 4 divided by 2x minus 3, all right? So you have this function now right here when it's factored out or expanded, okay? Now, the first thing I want to talk about is undefined. Where is a function undefined? Guys, check this out. Any function is undefined or restricted. All right, this is restriction, but I'm talking about domain restrictions. It's restricted. It's restricted if you have something that's 1, the number 1, over 0. Now, think about it like this. If I got a pizza, right, I can't have one of no slices. All right. It doesn't exist. I don't have a pizza. All right. I can't have, let's say if you had 100 over no slices. Guys, you can't have 100 of nothing. That doesn't make sense. So this is undefined. All right. So basically what happens is you take the denominator. You're going to find your domain restrictions. So if you went 2x minus 3 and set that not equal to 0, and the reason you say not equal is because it's going to be a restriction. I'm going to show you how. If I add 3 on both sides, that's a 3, guys. There we go. Plus, oh, shoot. Let's go again. Plus 3, plus 3. There we go. Add 3 on both sides. You get 2x is not equal to 3. Then we're going to divide by 2. And when we go 3 divided by 2, all right, so we cancel over here. I'm left with x not equal to 3 over 2, all right, which is this restriction right here. Now, let me show you why this is a restriction. If I take this denominator and I were to plug in 3 over 2, right? What happens is this, 2 times 3 over 2, that cancels, right? Or if you want 2 times 3 is 6, 6 divided by 2 is 3. So now you have 3 minus 3 in the denominator, right? Well, 3 minus 3 is 0. Again, you can't have something over 0. It's undefined. Does that make sense? I hope it does, okay? 3 minus 3 is 0. We can't have 0. It's not real. That's like saying I got 100 slices of pizza out of no pizza. There's no pizza. You can't have 100 slices. It doesn't make sense. So this thing is undefined at 0, guys, or excuse me, undefined at 3 over 2 because it would make our denominator 0, okay? So that's why you have a restriction right there. I just wanted to point that out, guys, before I solve the rest of the problem so you understand your domain restrictions, okay, and why that's right there. Now, anyway, back to this. After you factor the numerator, all right, you cancel, and what's left? Just 3x plus 4. All right, but you still have this restriction right here. For this function to work, any number will work but that number right there, okay? So now let's look at this you try. We're going to do f times g, or f times g of x. All right, so we have f and we have g. So I have x plus 2 times x squared minus 4. All right, well, FOIL, guys, FOIL. All right, FOIL. Or you can separate it out like I did earlier. And you can go here, let's move this. You can go x times x squared minus 4. And you can do plus 2 times x squared minus 4. This is essentially FOILing, guys. You get x cubed, all right, minus 4x. And you get 2x squared minus 8, okay? Now we put that in descending order in terms of the degree. So x cubed plus 2x squared minus 4x minus 8. All right, there are no like terms, so this is your final answer. Ooh, I almost messed up my, oh snap, minus 2x squared, no, minus 4x. I'm sorry, y'all. I messed that up, minus 4x minus 8. Anyway, there's your final answer, okay? Now, for the division portion, we're doing f divided by g. So here's f, and we divide it by g at x squared minus 4, okay? Now, first off, I'm going to do the domain restriction, okay? For the domain restriction, here's the denominator, x squared minus 4. If I take that and set it not equal to 0, then we solve it, plus 4 on both sides. All right, you have x squared equals 4. Then remember right here, you got to take the square root to negate that square. Now, who remembers the rule, all right, of when you take the square root on both sides? Hopefully you guessed it. You get x is not equal to, oops, forgot the not equal to right there, plus or minus. When you take the square root on both sides, plus or minus 2, okay? Now think about it. I just want to show you. If I put 2 right here, 2 squared minus 4, 2 squared minus 4, 2 squared minus 4, that's 4 minus 4 is 0. Remember, we don't want 0 on the denominator. If you put negative 2, and square that. Negative 2 squared. Negative times a negative is positive. So negative 2 squared minus 4. All right, that's 4 minus 4, which is 0. All right, we don't want to get 0 because, again, you can't have something out of nothing, right? So there's our restriction. X squared or x cannot be plus or minus 2. There's our restriction. All right, don't forget your restriction of the domain. Now, let's go ahead and simplify this while we're at it. When I simplify this, I have x plus 2, and by simplify, factor this. All right, this is the difference of 2 squares. So we factor this, so we get x plus 2, and we get x minus 2, okay? But anyway, what cancels? This cancel. All right, now we have what's left at the top. All right, this canceled out, so what's left, guys? Hopefully you remember it's 1. There's not 0. Somebody's go, oh, 0. No, guys, it's 1. All right, there's a 1 always there. All right, because you have 1 on the outside of this. It doesn't matter. 1's there, okay? All over x minus 2. Here is what's left. All right, f divided by g is 1 over x minus 2. Here's your restriction, okay? All right, let's go ahead and go to the back portion. I need to clear this off because, again, I was working on this earlier. All right, now we're looking at composite functions, guys. This term right here, f of g, I like to explain it like this because you guys like simplicity, you know what I'm saying? Means put g inside of f. All right, put g inside of f, meaning here's f of x, right? I'm going to take g of x, which is over here, and I'm going to put it inside of f, like so. All right, f of g means g inside of f. On the latter side, if you had g of f, all right, that means take f and put it inside of g, like so, okay? Put f inside of g, all right? Now, let's look at this first example right here, f of g of 4, okay? Well, if you do what I just said, f of g of 4, all right, g's on the inside, which means this is f of g. Let me show you how to get to this answer 8 right here without going through all this, all right? If you take the g, here's g, 7 minus x, right? Put the g inside of f. Here's what happens. We're going to take g and put it into this. So you have 2 raised to the 7 minus x. Now, you're like, why is that raised to 7 minus x? Remember, I had 2 to the x, right? I put g inside of this function, which means I substituted where the x is for f, I put the g. All right, so instead of 2 to the x, I put the function g right there. All right, I put the function g right there. So now I have 2 to the 7 minus x. All right, because this is 7 minus x. I put it in place of this substitution, okay? So now I have 2 to the 7 minus x. So now the question is, well, what is the value we're going to evaluate for? And guys, here's the function we're using, 4. All right, do it one more time. This function, 4. All right, so look, if I do this, I end up with 2 raised to the 7 minus 3. 7 minus 4. Right? And what's 7 minus 4? 3. So I have 2 cubed. Well, what's 2 cubed? 8. That's my final answer. All right, 8. So again, f of g of 4 is 8. That's how I got to my final answer, guys. All right, right here, what happened was, and I'm just showing you, now that I've showed you my way, how I like to evaluate these, what happened was they evaluated g of x first, which is right here, 7 minus 4 for the 4, because that's the internal function. 7 minus 4 is 3. And then they took the 3 and plugged it in for x. 2 cubed is 8. All right, that's one way to look at it. That's fine. If that's what y'all did in class, great. You like it, you love it, go with it, okay? For me, I like just doing the composition, and then plugging in what I need to evaluate. You know what I'm saying? I plugged in the 4 right here once I simplified it. And boom, got the same answer, okay? Same as that way, guys. It's doing the same thing. It's just writing it different, I guess. All right? Actually, I'm going to leave that right there so you guys can see it if you need to. All right, over here, you have G of f of x. All right, G of f of x. Well, what we're going to do is I'm going to put f inside of G. So remember, G, guys, is 7 minus x. I'm going to put f inside of that. So instead of having 7 minus x, what you have in place of x is f. 7 minus 2 to the x. All right? So in place of 7 minus x, I put the f in it, so into the place of x. So 2 to the x is f of x. Now we're evaluating for the number 4. So you have 7 minus 2 to the 4th. Well, 2 to the 4th, all right, just 2 to the 4th, all right, not negative 2. Somebody wants to go, oh, it's negative 2. No, 2 to the 4th. All right, but even still, let me do that so you guys know. 2 to the 4th. 2 to the 4th is 16, so I have 7 minus 16, which is negative 9, which is our answer, negative 9. So f, oh, I'm sorry, not f, but G of f of x, or f of 4 equals negative 9. All right. Again, if you guys went through it this way, where you solve the f of 4 first, so 2 to the 4th, 16, and then plug the 16 in, 7 minus 16 is negative 9. That's fine. It's the same thing. All right. I just like to go ahead and put the composition together and evaluate it, okay? All right. Let me erase so I can have some space. Edit, clear the ink. All right. Let's work on a U try. Here we have f of g of 3. Well, again, guys, if I take f of g of x, all right, f of g of that, that means g goes into f. So that gives me, put the g in place of this x. So 2x squared minus 3, right? Well, what's the number we're evaluating for? It's 3. So that gives you 2 times 3 squared minus 3. Well, what's 3 squared? 9. Okay, so 2 times 9 is 18. And 18 minus 3 is 15. So f of g of 3, hold up, need more space to write that. So f of g of 3 equals 15. All right. Again, just for the sake of it, I'm going to show you the other way. If you were to evaluate the internal function first, g of 3, you would go 3 squared is 9. Then I take the 9, plug it into f. So you have 2 times 9 minus 3. That's 18 minus 3, 15. All right, same thing. Okay, same thing. Over here, we have g of f of 3. All right. Well, I'm going to look at g of f of x first. Put f inside of g. So we have g is x squared, right? G is x squared. Well, instead of the x there, we're going to put f. So 2x minus 3 and squared, because it would have been x squared, right? So now we got to evaluate in terms of 3. So if I take 3 and put it here, 2 times 3 minus 3 squared, right? That's 6. 6 minus 3 is negative. 6 minus 3 is 3. And 3 squared is 9. All right. So g of f of 3 equals 9. All right. Equals 9. Okay. All right. Let that sink in. Let's move to number 4. So look, my lights came back on. Here, given that this is f of x and this is g of x, guys, this is doing the same thing we just did, composite functions, without the number. We're not evaluating for a number, okay? So f of g means put g inside of f. So here's g. We're going to put that in place of f, all right, or inside of f. So where that x is, see it's 3x minus 5, 3x minus 5. Well, instead of x, you have g. You got to put g in there. So you have 4 over x plus 2, okay? That goes into parentheses right here. It should be like that. All right. Anyway, we got to evaluate this, okay? And when you evaluate it, you guys know how to add a whole number, or excuse me, multiply a whole number times a fraction. Remember, this is 3 over 1. So you multiply straight across. 4 times 3 is 12. 1 times the stuff down there is the stuff down there. X plus 2. Okay? And then minus 5, because the minus 5 is still there. So there's your final answer for that composite function. All right, we don't have to evaluate it, so we're here, okay? And then you got to find this right here is the domain restriction again. If you take the x plus 2, set it not equal to 0, solve it. You get x is not equal to negative 2 like this. All right, remember when you have a fraction, you have a restriction. Fraction, restriction. All right, fraction, restriction. Fraction, you have a restriction. Okay? Over here, we have g. This is g, 4 over x plus 2. All right? Well, we're going to evaluate it for g of f, which means put f inside of g. All right? So what we got to do is, where that x was, we need to put in f. So that is 3x minus 5. Right? 3x minus 5. So now, evaluate that denominator for like terms. The only like terms you have is negative 5 and 2. Where negative 5 plus 2 is going to give us minus 3. So 3x minus 3. All right. There's your simplified form. So now we got to find our domain restriction again. Let me do it in another color so you can see it. We have 3x minus 3 not equal to 0, right? What that does for you, add 3. So you have 3x not equal to 3, right? I just added that 3 to the other side. And then you divide by 3 here. You get x is not equal to 1. All right, so that's where that restriction came from. Again, fraction, restriction, fraction, restriction. Y'all got that? All right, for the U try. The U try here, it says find f of g of x. All right, again, this is f of g, okay? F of g, all right? Well, g goes inside of x. So here's g. We're going to place it inside of f. All right, it's going to go right there. So you have 3 times the square root of x plus 2, right? Take this whole function and put it in place of f, all right? Then we evaluate that. Oh, oops, minus 4. See, that's minus 4. That's x minus 4. Distribute 3 square root of 2. Square root of x, sorry. Plus 6 minus 4. And then right here we have like term 6 minus 4. So we end up with 3 square root of x plus 2. But you have a restriction, guys. All right. What's the smallest square root you can have, guys? Think about it. Square root of 1 is 1. Square root of 0 is 0. There's no square root of a negative number. So x has to be greater than 0, guys. Greater than 0. When you have a radical, x has to be greater than 0, period. 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 Because this is the smallest square root. All right. X, square root of x is greater than 0. If you were to solve it, like if you did this, square root of x, and then square this side to get rid of the radical, you'd have x is greater than 0, because 0 squared is 0. There's your restriction right there. X has to be greater than 0. So here's your answer. 2 times the square root of x plus, 3 times the square root of x plus 2, where x is greater than 0. That's the answer. Okay. Greater than or equal to 0, actually. Equal to, because it equals 0. 0 will work. Okay. So greater than or equal to. Sorry about that. Now, last problem here. All right, word problem. Not too tricky, I don't think. Let's dig in. It says Lane has 2 coupons for the shoe store. One is for $10 off. The second one is, on this problem, Lane has 2 coupons for the shoe store. One is for $10 off. Mickey, calm down. So one is for $10 off, and the other is for 15% off. Man, God. He was told he can use both coupons, but which coupon should he use first? All right. The original price is $10. All right. How much will he end up paying? So we got to look at both scenarios. All right. You got 2 coupons. You can use both coupons. You got to figure out which coupon you want to use first. So first, let's address this. The first one says $10 off. All right. How can I make a function for f that represents $10 off? Anybody? That's a real question. X minus 10. Cool. X minus 10. All right. So X minus 10 will represent $10 off, right? You got the price of the shoe. We're going to subtract $10. All right. The other equation would be 15% off. All right. How do you represent 15% off? X minus 0.15. How about, no, let's just do 0.15x. Let's use that. 0.15x. Or, better yet, let's do x minus 0.15x. How about that? Right? So you have the price of the shoe minus 15% off the shoe, right? Yeah, there we go. So look, we're going to figure out which coupon we can use first to give us the biggest discount, okay? So the first scenario we're going to look at is if we use the $10 off first. $10 off, then 15%. 15% off, right? So if we do that, we're going to do, if the shoes are $100, you would first do 100 minus 10, right? F of x, 100 minus 10 to get what? $90, right? So then you would use the 15% off, which is $90. Not 19. It's now $90, right? So you have 90 minus 0.15 times 90. All right. And that's $90 minus 15% of 90. All right. So 0.15 of 90 is 13.5. All right. So 90 minus 13.5 will give us what? 76.5. So the price of the shoe you would pay if you use the coupons with $10 off first and then the 15% off, you pay $76.50, right? Now, if you do it the other way, if you want 15% off, then $10 off. All right, what does that put us? So we go 15%. If we went $100, shoot $100 minus 15% of $100, right? Well, that's $15, right? So 100 minus 15 is $85. And then if we take off the $10, that gives us $75 even. All right. So this would be the way to go. 15% off, then $10 off.